or
What we gonna find?
This is Scientific American's 60-Second Science. I'm Karen Hopkin. This will just take a minute. As we recover from the holiday weekend, there's some intoxicating news on curbing the effects of alcohol. In the May 29th issue of Cell, This is Scientific American's 60-Second Science. I'm Karen Hopkin. This will just take a minute. As we recover from the holiday weekend, there's some intoxicating news on curbing the effects of alcohol. In the May 29th issue of Cell, scientists report discovering a gene that controls fruit flies' sensitivity to ethanol. And if that just sounds like tipsy talk, the findings suggest that a couple of current anti-cancer drugs might find use in treating alcoholism. Some flies, like some people, just can't hold their drink. One sip and they're tripping over their own wings. So the scientists set out to search for the fly genes involved in alcohol sensitivity, and they turned up a gene they call happy hour. Flies with the normal version of this gene are liquor lightweights, while happy hour mutants can drink their fly friends under the table. In the normal flies, happy hour blocks a hormone called EGF, and the scientists found that two anti-cancer drugs, which also inhibit EGF, make boozing flies more woozy, a feeling that's as unpleasant for flies as it is for people. Rats, too, will take a nip and say enough when they're on these drugs. Robbing booze of its buzz is one way to attack alcoholism, which means that, at least genetically speaking, it's good to have a little happy hour. Thanks for the minute. For Scientific American's 60-Second Science, I'm Karen Hopkin.
Hello guys, this is highlighting incorrect. Everyone know this is a PT Pearson subscriber, Happy New. So this why part of listening. So this is a highlighting incorrect. Some guys speakers describe this passages and read this passages. Sometimes he wrong passages. So I found this one. This one wrong.
Discovering.
She tell this one wrong. So this is highlight incorrect. So this one minus. When I touch the minus, then minus plus this one. So I try another one.
Some dinosaurs were really huge, and now we may have a better way to estimate just how heavy these giants were. Researchers have developed a method.
Look, she said this one estimate. So this one no estimate, this one undevelopment.
To weigh dinosaurs based on laser scans of their skeletons. The study's in the journal Biology Letters. Looking at a bare human skeleton, how would you guess whether its owner was chubby or svelte? If you calculated how much space the fully fleshed body occupied, you could multiply that volume by tissue density to find the weight. Researchers laser scanned 14 modern mammal skeletons to create digital models of each body. These 3D models were unrealistically scrawny, with skin stretched tight over the bones. But their undersized volumes were consistent, measuring in as 21% less than the actual animals. Based on this information, the researchers scanned Giraffatitan bones, added 21% to the digital model's volume, and then calculated the dinosaur's weight, about 51,000 pounds. The technique could become the preferred. Some dinosaurs were really huge, and now we may have a better way to estimate just how heavy these giants were. Researchers have developed a method to weigh dinosaurs based on laser scans of their skeletons. The study's in the journal Biology Letters. Looking at a bare human skeleton, how would you guess whether its owner was chubby or svelte? If you calculated how much space the fully fleshed body occupied, you could multiply that volume by tissue density to find the weight. Researchers laser scanned 14 modern mammal skeletons to create digital models of each body. These 3D models were unrealistically scrawny, with skin stretched tight over the bones. But their undersized volumes were consistent, measuring in as 21% less than the actual animals. Based on this information, the researchers scanned Giraffatitan bones, added 21% to the digital model's volume, and then calculated the dinosaur's weight, about 51,000 pounds. The technique could become the preferred way to estimate mass based on skeletons, improving our understanding of how extinct species lived and moved, and helping paleontologists make earth-shaking discoveries.
Guys, looking, I have a correct 1, 2, 3, 4. Just one miss. Good. Now I take the out of 5 to 4. Another one.
Astronomers have discovered a trove of galaxies that are virtually invisible. Astronomers have discovered a trove of galaxies that are virtually invisible because they're made almost entirely of dark matter. The Subaru telescope in Hawaii spotted 854 of these oddballs, which are referred to as ultra-diffuse galaxies, by detecting what little light they do produce. They were all found in what's called the Coma cluster of galaxies. The report is in the astrophysical journal Letters. Of course, scientists still do not know just what dark matter is, but they can detect its presence through its gravitational effects on the normal matter that we can see. That's how we know that dark matter seems to be ubiquitous in the universe, especially in these newly found, barely visible galaxies. Many of these galaxies are about the size of our Milky Way, but contain just 1,000th as many stars. Researchers estimate that dark matter accounts for 99% of these galaxies' mass. How such objects could form is a mystery. They probably started out with a healthy complement of star-forming gas, just like normal galaxies, but somehow lost it. The gas might have blown away as the galaxies moved through the Coma cluster, or maybe other galaxies' gravity dragged it off. Further study of these ultra-diffuse galaxies should clarify the situation, and may even shine some light on the fundamental nature of dark matter.
Oh, one mistake. 1, 2, 3, 4, 5, 6. 8 of 6 good, 1 mistake, and 1 wrong. So wrong, this one minus 7. If I have a wrong, that's this one minus point. I have a 6 done. 1, 2, 3, 4, 5, 6. But I have a 1 wrong. So minus 1 out of 7 out of 5. This is very easy, but another side difficult because minus point. Another one.
What
Please
had the
like.
legs of a gator and the jaws of a fish? What had the legs of a gator and the jaws of a fish? Why, the earliest land animals. Because a new study shows that animals evolved weight-bearing limbs long before they had the chompers to really take advantage of a terrestrial diet. The research is in the journal Integrative in the journal Integrative like what had the legs of a gator and the jaws of a fish? Why, the earliest land animals. Because a new study shows that animals evolved weight-bearing limbs long before they had the chompers to really take advantage of a terrestrial diet. The research is in the journal Integrative and Comparative Biology. Scientists had suspected that the first four-legged creatures to haul their carcasses out of the ocean didn't belly up to the salad bar straight away, but they lacked definitive proof. Now, researchers have carefully examined the fossilized faces of 89 beasties that lived on land and sea some 300 to 400 million years ago. They probed the jaws for a range of biomechanical features, such as how much force they could give to their bite. The result seems it took tens of millions of years after setting foot on land to come up with a mouth that could munch on the greenery. Why the lag? Could be the critters had to stop being such mouth breathers and shift from using gills to using lungs, which freed their jaws to develop in new ways, and which left no more excuses to not eat their veggies.
1, 2, 3, 4. Mistake 3. Oh, this is bad. Hello guys, please like, please comment.
Aspirin is a popular painkiller, and chances are you have some in your medicine chest right now. You might even have some in your flesh and blood put a shirt on a chest, because a new study suggests that humans can make their own salicylic acid, which forms the bulk of aspirin's active ingredient. Scientists at Scotland's National Health Service previously observed that people can have salicylic acid in their blood even if they haven't recently swallowed an aspirin. Vegetarians have really high concentrations, which makes sense given that plants make salicylic acid, so fruits and veggies are full of it. But their recent studies suggest that not all of the chemical comes from the diet, because humans can take a precursor molecule and turn it into salicylic acid, results published in the Journal of Agricultural and Food Chemistry. The researchers say that people might make salicylic acid to fight inflammation or disease, which would also make sense because plants make the stuff to fight off infections. In fact, a recent study published online in the journal Nature shows how calcium released at the site of an infection tells plants to ramp up production of the protective compound. Just Mother Nature's way of saying, make 2 aspirin and call me when you flower.
Here's a strange tale of 2 previously unrelated food products. Here's a strange tale of 2 previously unrelated food products. First, chitlins, that delicacy of fried pig large intestines. They're well loved throughout the South, especially during the upcoming holiday season. But the smell of them cooking inspires significantly less affection because the cooking process sometimes smells like, well, feces. Researchers in Japan thought that cilantro could help, because cilantro is used in a variety of cuisines around the world to mask smells, as well as to add distinctive flavors. And in a previous study, the research team had shown that cilantro can mask the cooking chitlin stench. In the new research, in the Journal of Agricultural and Food Chemistry, they isolated cilantro's volatile compounds and tested each one for its odor-fighting power. Many seem to lessen the stink, but one in particular, according to human sniffers, entirely cancels out the odor. It's called EE24-undecadienol. It works at a very low concentration, 10 parts per billion, so you can't smell the compound. It's not masking the chitlin odor, it's actually neutralizing it. So it's not just better living through chemistry, it's better chitlins too.
Two mistake.